Welcome back to our new lecture. Now we are starting to understanding in details the visual electrical inspection. As I explained to you in the previous lectures that we are review all the standards, we are review all the requirements of most of the conditions. I try to pressing the time regarding to this one, and I try to explain to you the headlines and also the important points. Visual electrical inspection. So we have a lot of steps before we are starting our visual inspection. Number one, we must be check and review the last as-built drawing. So if you are going to any building, any hospital, or even if we are going to inspect the construction electrical system, we must be always looking and search and get the last approved drawing, and also be ensured by official documents and official email that this drawing is the last approved drawing. Then we are going to plan our visual inspection. What we are going to visual inspection or to RCD test and thermal image scan, whatever. So for example, if we are going to plan for the visual inspection, in this case, we not need to open any DB. Just going to the facility, for example, we are going to the hospital, or to the hotel, or to the oil and field gas, for example, chem. So just we have only the papers and pen plus the permit to work. Then we are going just make a look, just focus on the switches or the DBs, or just only looking. But if you are going to test the RCD test, in this case we have another type of permit, which is give us the permission that we can make a trip and return the main circuit breaker on and off during our RCD test. Because when you are going to make or to apply the RCD test, we need to get approximately 8 times make a trip with this RCD. 6 times to take the readings, including 2 trips. It must be not a trip, I will explain to you later. Plus we must be take 6 readings, then we will take another 2 readings regarding to the amount of leakage current. Also, sometimes this visual inspection including the thermal image scan. So the thermal image scan, mostly we need to open the door of the distribution panel or of the consumer unit or consumer distribution unit. So, and this must be done, I mean that the thermal image scan at the DB with full load. I mean that all the load, what we have the load, AC units, we have another equipment, we must be all of them switch on. So the thermal scan must be takes image when under full load. So whatever this action of visual inspection, I mean that we are going to only visual on the visual with RCD test or with visual with RCD and thermal image, we need a special limitation access to the open DBs according to the permit to work requirements. The third point, that we must be prepared for the exact test devices. Check for the calibration certificate expire date. So all our devices that we are going to use it during our RCD test or thermal image, we must be sure that these devices are calibrated and also has a certificate which is still not expired. The fourth point, it must be prepared for the different type of panels. Key, because as you know, each panel or each distribution panel, in case we are going to open the door, we need a special key for this to open the door. We must be understanding what are the types of the DBs that we have it, and what are the keys that we must be prepared before starting our work. So in this case, and also we must be prepared all the exact tools that we will need it during our inspection job, especially if we are going to open the doors of the DB. Some DBs without double door, so in this case we must be consider this special requirements to open the DBs. And also in this case we must have a special permit regarding to the disconnect and connect the main circuit breaker of this DB. Then after that we must apply for the toolbox for your staff. When you are going to plan for visual inspection, if you have a staff with you, for example electricians or other people, so before you start any work and before you going to apply all the rules regarding to the visual inspections, you must explain and toolbox explain all details and all the job that you are going to do it for your staff, because it must be their understanding what are they doing, what are their responsibilities. So therefore always you must keep in your mind the process of the visual inspection, which are starting from checking, a plan, prepare, proceed, and toolbox. This is we must all the steps must be applying before start your visual inspection. So during our visual inspection we have two ITR, which is an inspection test report. In case we are going to just visual inspection, we can use this chart, and also I share with you a document with you. While if you are going to make the electrical inspection for the thermal image and RCD test, also we have another ITR. So for the visual inspection always we have two ITRs. This is for the only visual inspection, while this for the RCD test and for the thermal image if any requirements. Just I want to explain to you something. For example, here visual inspection of amount damage and etc. You check all these items. So if it is okay, you tick okay. If otherwise, if it's not applicable, you say not applicable. So this item or this topic we don't going to apply in this our inspection. You just take the not applicable. Otherwise, if you have any problems, for example with the DB, with the DBIB, you can tick as a punch list. While here, for example, here this is the value of the RCD. Here the device that you are using with the calibration expired date, and here the readings of the RCD that you are going to inspect, and then put your signature, your name, date, and your company, whatever. And this is which is the third party. He must be signed and understand. If you have any comments, you making mention here, so your client or your customer, in this case, involved with all the issues that have with the distribution panels or with the RCD test. So, in case we are going to make the visual electrical inspection without RCD test or without thermal image, we just use this ITR or inspection test report. While if in case we have RCD test or thermal image scan, we can use also this form. So in any case, as you see here for the electrical inspection, now during this inspection we open the main door of the distribution board and we check for all the visual inspection. We don't touch anything, just make the focus, and we will see here, for example, this is good condition of these wires. Here all the wires with the bootless, all the wires with the bootless, and also here the numbering. While here very nice view regarding to the wires, but we have big problem, which are this area. This you see these wires, it will be out of installation rules. So this wires must be going underneath the cable tray, and also it must be with all. You see here there is a tag, okay. There is what is there is a numbering, everything okay. Here we have a dangerous sign, okay, very nice. Here very nice wiring, but you see here this wire not allowed, and this wire is not allowed. This wire not allowed. This wire also not allowed. As you see, this wires come over the cable tray, so this is, you must be rejected. It must be, make it a bunch, and after that, who is responsible to make this maintenance? He must become also to remove all the covers of the cable trays and reinstall the wires inside the cable trays, then close the covers. After that, you are going again to check by yourself, then you can remove the punch list that you are put it in the previous or in the primary electrical inspection report regarding to the visual inspection. Here this is samples during my inspection. For example, I see have you see this one? This is the DB number, and as you see here, we have a lot of opening area. It is not allowed because this is not out of the IP standard, so it must be all these holes. It must be closed by the required materials to make all this area closed. So in this case, to make the return this GB to put it under the required standard. For example, here, as you see here, for accommodation, so this we don't have RCD, so this panel without RCD wire, they use here only MCB, and it is not allowed because this is for the accommodation room. So it must be there's here a residual circuit device to make the protection of the room. You see here, for example, there is no cover, even if there is no stripping wires, but it must be make a plastic cover to cover this box. As you see here, for example, we have a broken or damaged socket, which must be changed. So all this you will make it as a punch list during your primary visual inspection. As you see here, this is a read that I inspected before. As you see here, we have a numbering. We don't have also RCD here, as you see. Okay, we have a big problem here. Why? Because this electrician, he comes and install this bus bar while he cutting in unprofessional way. He must be this cutting professionally and must be isolated, not like make the bus bar like this. As you see here, you see this bus bar. This is very dangerous because this is line conductor, bus bar for line conductor. So you must be isolated and not cut it like this one. This first. The second one, as you check here, this is the bus bar for the neutral. This is a neutral bus bar. This is blue one. What they are doing, they used the earth wire and connected to the neutral bus bar to send the neutral conductor to other place. So it must be this wire, not green yellow wire. It must be black wire. Otherwise, they can use the black tape for all the wires and tape the wires in black. So when you are going to inspect, we will check it as a black wire. Also, we have big problem here. As you see, this area, and you see this area, for example, they don't use a bootless. So this is a loose. This is during the time, because when you tied the screws, now without using the bootless with the wires, so in this case, after 1 week, 2 weeks, 3 weeks, maybe 1 month, it will be give an flexible movement. So whatever this may be less than millimeter or 0.01 millimeter. So whatever this distance or flexible distance, in this case, this distance will cause a loose connection for this panel, and already in this case all the neutral wires will be melted, and we are going to dangerous situation. As you see here, also this wire, There is here some damage for this wire. Why? Because sometimes maybe this wire during they use the screwdriver or something like this, so this make here and weak effective for this wire, so it must be take care. At least we must be make a tape in this area, so you can check for this one. Also you can see here inside this bottom of the wiring system, you see how they don't use a bootless, and they put two wires in one hole of the circuit breaker or on this device. So therefore you see very bad connection. Even here they use two wires, yellow wires, phase or second phase. This is RST. So in this case you see they use here bootless, but they are not connected properly. So as you see, we have a lot of damage here, and this may be caused a dangerous, even sometimes maybe make a short circuit between the phases. And also as you see in this photo, this is the bus bar. You see how they are cutted. This is unprofessional electrician work done by this electrician, and this electrician I punish him that time, because he must be not cutting like this. There is a rules that he cut this bus bar, and plus it must be isolated professionally. As you see here, for example, this is a neutral bus bar. It is broken for this one. This bus bar must be fixed here, so they are going to change off this neutral bus bar. As you see here, for example, this neutral was melted on the body of the, this is the panel, this is the distribution panel, and this is PVC panel. This is when you remove this panel, you will find this effect as a melted of this wire. This was melted. This piece is cutting from this, because this wire was melted 100% with the body. So this is very dangerous, and because as you see here, we don't have RCD, and also in this case this not going to trip. This is going to melt, and this is not to trip. So this is very dangerous, and 100% they caused a fire for the system or for the accommodation. As you see here, we have, this is a melting, because they don't use bootless. Here also there is no numbering, there is no any tag for the wires, and you see here this phase. You see this is a 3-phase 4-pole earthing circuit breaker from Schneider. So this phase melted, and as you see here, this is melted and be not tripping. Why? This is very important reason we must be discuss for this one, because here we have a loose, and this circuit breaker, it is not compatible to use here, because they are use RCD with 300 milliamperes. So therefore, as you see here, the loop impedance, it will be changed, and there is no trip. Also there is a heat and loose wire, loose connections. Also it is not a trip. So therefore we must be select the exact and correct RCD to install in the correct position, to use it in the correct end user regarding to this one. As you see here, this is another panel. You see here the bus bar not installed incorrectly. Why? Because this is, or these Hager circuit breakers, and these Havels, so these bigger than the others. So therefore the bus bar not installed properly as in touch way like this one. So in this case, before they install this one, it must be removed, these two circuit breakers Havels, and change it by Hager, and also or change all of them by Schneider or whatever, or change what you have in your store to make all this as a one set. Therefore, and then you are going to install the line bus bar. So therefore this is also make it a big dangerous punch list. As you see here, all the wires, there is no numbering, Some wires there is numbering, the others there is no numbering. And you see here, also here we have bad connection because they don't use, and this is 2 wires installed in this circuit breaker and without using the bootless. As you see here also, we have a melt wire here. It's very clear regarding to this issue. So the bootless, we have a lot of types of bootless, and also we have pictures of the dies. We have a lot of pictures of the dies. We have a lot of types of the dies, and each type where you are use it. For example, this is LS/16WF. This type of applicable terminals, which is used for wire and fearless 6 to 60 millimeter or 10 to 5 AWG. For example, this is LS26TW. This is the picture of the dies. This used also for the end fairness 2 multiplied by 0.5 or 0.75 or 1.5 or 2.5 and 4 and then 6 millimeters. We can use this one. We have a single and we have a double. Here we have a single, we have a double. So therefore, for example, for these wires, we must be use the double fairless or double bootless to install these wires. And also, as you see here, the diameters of this one, it will be different from 0.5 up to 6 millimeter, and also we can find it for 10, for 16, for 25. So these are the picture of the dies, and these are the applicable terminals, and these are the item numbers, and these are when you are going to use it. This is, you can make a small copy of this one and put it in your pocket. From time to time you will enter all these items going in your mind, or keep it in your mind memory. So this is very easy, but when you are going to inspect it from time to time, you will be keep it in mind, and it will be very easy in that time. Just make a look. The first look, you can understand all the details, requirement, and the conditions for the connection or for the connections of the wires. So as you see here, we have different panels. This is very good panels. As you see here, we have a numbering, everything going okay. They use bootless, everything. You have here residual current monitoring system, and also you have all the requirements to cover this dB. While here also we have fuses, earth leakage fuses, and I explained to you the fuses, the types of fuses, and why we are using the fuses in sometimes. And you have here, you see this is a type of fuses, this is another type of fuses. They are here, but here we don't have a numbering, we don't have a tagging for the wires. We also, all the wires, they don't use bootless. So here we have a bunch list with a lot of items. While here everything okay, but also they don't use a bootless. Plus there is no numbering for the wires, and also there is no any tag to give you an indication for each wire where connected, and to where on the end of this wire also where this is going. As you see here, we have a small dB with holes, without covers. This is must be rejected and change the dB. And as you see here, we have a lot of loose wires. Here we have, this is out of tolerance because this is 100 milliamperes, so we cannot use it for the residual rooms or residual application. Also we have, for example, here we have a waterproof 13 ampere socket. This is broken in bathroom. We must remove it and change it. Here this is a kitchen, and they are used a normal type of socket. We must be changed to the waterproof. Here also they don't use bootless. They don't use numbering system. As you see, each two wires going as slipping and going to inside and then use tied it by the screws. This is not electrician. And you see here also this black wire we have overheated and it will be damaged and cause condition of dangerous. This is damaged wire, it must be changed. Here as you see they use a tape, so this is not allowed here because the tape it must be used with a good type of tape. This tape was open and also the connection between this part and this part they are used here for extension because this wire is not going to the inside, so therefore they cut it and take another wire and connect it here to reach this connection to the this circuit breaker. As you see here we have a thermal image. Here we have a big loose connection in the panel. You see this one, and this as I remember this approximately 52 degrees centigrade for this one. Thank you very much. See you in the next lecture.